Welcome to week 4. This week we're going to talk about quadratic equations and inequalities. This is chapter 10.2 through 10.5. So first of all, let's just look at what our general form for a quadratic is. It's this a times x squared plus bx plus c all equals 0. Okay, so where a, b, and c are constants and x squared, x are variables. Previously, we've solved these equations by factoring these equations, or we've been able to solve them directly. Maybe we don't have that x term in there, something, and we can just square root both sides. But generally, it's not always possible that we can factor equations like this, or that we'll be able to rely on some algebraic step to neatly solve them. So there is a general solution. If you have an equation of this quadratic form, it always has a solution of this form right here, where we have a minus b plus or minus b squared minus 4ac divided by 2a, where those are the constants that were in that previous quadratic equation. Okay. So note that this is actually two solutions, right? We have this plus or minus up here, so this means we have a plus and a minus value. So we'll see how we do that here when we do some examples, but basically you're going to have this minus b, and then we're going to either add this term to it or subtract this term from it. Okay, so always leads to two solutions. As a general rule, all equations have an equal number of roots or solutions as they do the highest power in that equation. That's not really clear. Let's look at an example. For example, this 3x squared plus 1 equals 0. It has two solutions because we have the highest order is a power of 2. Another example here, this equation has 6 solutions because we've got a highest power of 6. Okay, so now we'll talk a little bit more about this later. It'll turn out just that not all of those solutions are in fact what we call real. There are imaginary solutions. We'll talk a little bit about that later. We're not going to worry too much about it, but I just want you to know that they do exist, because it is always nice to know that if you have an x squared or an x cubed, that you're getting 3 values, or at least see where 3 of those values are. It is also possible to have a degenerate value, one where you have one solution but you actually get it twice. You may come across that in homework, but basically that would be the case where where this value here is 0. Okay, so it's a very rare, it's a very simple, or a very small case, but it does happen. So, okay, let's look at how we solve this. So we've got an equation, and this should be equal to 0. Okay. Oops. Oh no, running away from myself, sorry. Okay. So we've got this equation here where our a value equals 1. If we don't have anything out in front, it's 1. This is the nice simple case. B equals 2 and c equals negative 15. We'll recall our general form of this equation. And first of all, we know that we can't factor this because there's not two values that multiply together to give us negative 15 here. So we could try to factor, it's always a good idea to try to factor it. This equation, while it seems, nice and simple, it can get unruly at times. If you'll end up with square roots and stuff. So it's always nice to check if you can factor things first. But this does always work. So it's a nice fail-safe. Okay, so here's our general form. So now all we're going to do is take these constants and plug it into our equation. And then we're going to simplify. So I've just taken all the a, b, and c values and plugged them into their respective spots here, which we can simplify. Gives us negative 2 plus or minus, or plus and minus, square root of 64 all over 2. This square root of 64 can be simplified. That's actually just equal to 8. So our two solutions are x equals negative 2 plus 8 over 2, and x equals minus 2 minus 8 over 2. Okay, so here's our first solution, minus 2 plus 8 over 2, which equals 3. And then our other solution is minus 2 minus 8 over 2, equals -5. So we have two solutions here. Okay. Let's look at another example. Again, this is one that cannot be factored. 5. There's not a number other than 5 and 1 that can be multiplied to get 5, and 5 and 1 don't add or subtract to give us 1 out in the front. So, okay, good. Here's our general solution here again. And again here, A equals 1, B equals 1, and C equals 5. So just plugging those numbers into our equation, very straightforward here. We're just plugging into that equation. We get this, which simplifies to this. So we can't further simplify this equation here, but there is something very strange about this equation, right? We haven't come across it. Maybe you've come across it before, but we actually end up with a negative square root value. Okay, how do you if you think about the square root, you shouldn't really have negative values inside of a square root, because anytime you multiply a number by itself, you always get a positive value, right? At least that's what we're used to thinking about. But it turns out that you can, if you do have a number like the square root of -1, so you always, so the square root of -1 is what we define as being I, which is an imaginary number. Okay, so the square root of a negative number is an imaginary number. Let's not worry about this too much. We don't really need to go into it, but I just want you to know that it does exist, because you could come across it in your homework problems, okay? You'll come up with a problem where you end up with a negative square root value. Just know that it is okay. It's always good to check your work, make sure that everything did work out okay, but it is possible to have this. There are these imaginary numbers, they do exist, despite the name. And in fact, they're very useful. In physics and engineering, they're used all the time. So imaginary numbers are a very useful thing. We're not going to get into it too much into this class, but they do have a use. And that's the end of this first video. We'll go into some more examples of using the quadratic equation in the next video. We're going to look at when your equation doesn't look in this sort of standard form, how can you get that equation to look like this: ax squared plus bx plus c equals 0. It's a very powerful tool, and you can use it to solve even higher order terms or much more complicated looking equations, and you will definitely run into these kinds of problems in your homework. So check out the next video.